Always, guys. Cool. So quadratic equations now. Quadratic equations, it's all now you will see them with um this, right? So anything with an x squared is the highest power. No, not anything with exponent 2 as the highest power, it becomes a quadratic, right? Even if you have it in a form of ax squared plus bx plus c, right? Even if you have it in this way, it still qualifies to be called a quadratic function, right? And of course here you will see that c is actually the same as q, right? So I will remove this one and we'll talk about this one, right? So parabola, what it looks like this, right? And it looks like this, right? So this is a parabola, this is a parabola. What determines whether your parabola will look like this or like this is this gentleman over here, right? So this gentleman, I would do this and I would do this, right? So this gentleman over here, if he is negative, so we have a negative a, this gentleman, no, not we have a negative, if this gentleman is negative, right, we have a graph that looks like n, right? We say it's frowning. I can't frown, but yeah, this is a frowning or n, right? You have a negative a value. And then for if you have a positive a value, your graph will look like this, and we call this a smile. We have one, yeah, it's a smile, so that's the smile, right? So yeah, what determines whether your parabola looks like n or u is a, it, depending on whether a is positive or negative, then the sign or the shape of a parabola will be in that particular manner, right? Let's talk about this gentleman. This gentleman is very okay. It's the y value of your turning point, right? It's your y value of your turning point, of which I don't know, but I think for most grade 10 questions that I saw on quadratic functions, they were all the turning point, it was all on the y-axis, right? Let me just confirm, but that's what I saw. So if that is the case, right, then you would realize, I would say, for grade 11 and 12 and going further to university, we deal with parabolas that, yes, so that is true. So we deal with parabolas that sometimes the turning point is not on the y-axis, right? So what I'm saying is, you have a Cartesian plane, right? So in grade 11 and 12 and university, you will have parabolas that are somewhere here. You have this kind of a parabola, you will have this kind of a parabola where this is the turning point, you would have this kind of a parabola, you'd even have this kind of a parabola, right? So yeah, that's for grade 10, no, grade 11 going onward, right? But as for you guys in grade 10, the parabola you guys are focusing on, it has the turning point here, right? On the right, the turning point is exactly on the y-axis, right? Yeah, it's exactly on the y-axis. Yeah, so the turning point is just exactly on the y-axis, right? So then I will then say, that's why I'm saying it's the y value. You know, it's always the y value of the turning point, which in this case also that y value becomes the y-intercept, right? Where x equals to 0, because anywhere on this y-axis, x is 0. And then the y value is also responsible for a vertical shift. Now, we talk about vertical shift, we are talking about the q, what the q actually responsible for. Do you understand? Nice. Nice. Let's see what we can gain from doing a couple of examples. So you could get a question that'd be like, hey chief, look, can you find us the value of can you find us the function of this parabola? Let me call it g of x. So to find this, you already see the turning point, we have minus 3, and therefore you have y equals to ax squared minus 3. Because where is this minus 3 coming from? It's the y value of the turning point, which is the y-intercept. Do you know what I'm saying? Exactly. So now we can pick this point where you would substitute 5, a 2 squared minus 3, 4a minus 3, 5, and then you have 5 plus 3, almost at 8. What's happening? So you have 2 becomes 4, so 4, and then a, and then a, and then we transpose, then 4a, you have 8, then you have, you have 2 equals to a, right? And what does this say? This say therefore g of x is going to be 2x squared minus 3, right? You substitute 0 here, you're gonna get minus 3. You substitute what? 2 times 2, that is 4. Wait a minute. Oh no, it's fine, because you substitute 2, so here you're gonna have 4, so 2 times 4, which is 8. 8 minus 3 is 5. So yeah, we're good. Oh yeah. So this is your function, eh? This is your function. So I am telling you, with all the problems you're going to get, all the problems you're going to get, when you have the turning point, you substitute it first, you look for another point you have on your graph, you use that point to get to exactly where your graph is. Do you see? Cool. So now let's do this, ne? Now we know how to find the function. We know how to find the equation of a function. Now I want us to take this equation and plot it. So before you can plot it, here's the thing. A is positive 5. That means your shape, it must be like this. And then Q, you have minus 2. Therefore, you are here. Minus 2, that's your turning point. Right? That's your turning point. And usually, I will say, look, when you have this, find what? You can't find y-axis because y-axis is going to give you minus 2. So let's find x-axis where y equals to 0. 5x squared minus 2. Right. Yeah. I mean, there are many ways of doing this, right? One of the easiest way, right, it will be to transpose to 5x squared, and then you want x, so you divide by 5, and then you have this, and then you have x squared equals to 2 over 5, right? And then you put the square root, the side you like, plus or minus square root of, therefore x will be plus or minus square root of 2 over 5. So one of the easiest way to actually do it. But if you want to be fancy, my advice, don't try to be fancy, but if you want to be fancy, you can be like, here you have square root of 5 x to the power of 2 minus square root of 2 to the power of 2, and then you have difference of 2 squares. Then you have square root of 5 x minus square root of 2 square root of 5 x plus square root of 2. Come on, bro. Square root of 2, then you close your bracket, and then equals to 0. So then you equate each bracket to 0, say square root of 5 x equals to square root of 2, or square root of 5 x equals to square root of 2. Come on, bro. So okay, this is gonna be minus square root of 2. You divide by square root of 5, square root of 2 over square root of 5. square root of minus 2 minus square root of 2 over square root of 5, right? Which is exactly what we got. But don't try to be fancy, man. Don't try to be fancy. I mean, if you can be fancy without making mistakes, so be it. Yeah, but don't try to be fancy. So after solving this, we did get that x is equals to plus or minus square root of was it? Yeah, square root of 2 over 5. Yeah, so those points, they'll be here, so this is square root of 2 over 5, 0. This will be minus square root of 2 over 5 over square root of 5. I forgot square root of 5, and then 0, right? So now when you plot it, you're like and then we are turning here, then right, then you can find another equation on your graph to say not equation, another point, say x equals to 2, right? And therefore you have y equals to 5 into 2 minus 2, right? Oh, this is 2 squared, so you have 4 times, that is 20, minus 2, that is 18, right? So then here you like here you have 2 and 18, right? And then you are done plotting this one, right? So I will also say again, all the plottings also, this is the structure, right? You start with the y, you put it there, find your x-intercept, right? After finding your x-intercept, you can also find other values as well. Just maybe just 1 point is enough, right, to get you full marks. Yeah, so this is it, and I think we will see more when we do more examples. Away.